We're rolling. For those of you listening at home, hi Chili. Sorry I spazzed out in the first 5 minutes. We are playing with functions and their inverses. We want to find out when are two functions inverses of each other. Here are the 4 tests we've covered. Again, if you manually get f inverse by hand, look and see if it's the same formula or equivalent. You could also go the other way around. Take this formula and get its inverse by hand and see if it's the same as this. Number 3, again, which I would reserve for if they gave you graphs, check and see if the graphs are reflections over the line y equals x. If they are, then it works. The 4th is if you plug one inside the other, does it cancel down to x, and does it do it the other way around? It has to work both ways. If it only works f of g of x, but not g of f of x, then it's not a true inverse. So, stalled enough. What do you recommend? Okay, pick one. Number 3? You want to graph this thing? Okay, I wouldn't do number 3 then. Pick another one. Number 1. Okay. How do you get an inverse of a formula? Go.
Switch x and y.
Switch x and y. I don't see the y.
It's f of x.
It's f of x. In other words, replace f of x with y. It's interchangeable. So 3x minus 4 over 5. And then I'm going to do the inverse, which would be what while you're at it?
X is equal to 3 times y minus 4 over 5.
Good. So everybody see that? You have just taken the inverse. What I want to know is this the same formula as this? Now I have to do something first in order to see. Get y by itself. Ned, help me out. How do you get y by itself? What do you do first? Yeah, multiply both sides by 5. Okay, so we have 5x equals, cancel, 3y minus 4. Keep going. I want to get y by itself. Add 4. So now we have 5x plus 4 equals 3y. Keep going. Divide by 3. Cancel. I'm going to put this on the other side. Y equals 5x plus 4 over 3. What's your verdict? It is the same as g of x. So what can we conclude? Is this an inverse? Are these inverses of each other? Yes. One of the advantages of 1 and 2 is that you only just have to do it one way. You don't have to do both. For number 4, you do have to do both directions. Okay. I'll show you what number 4 looks like in a second. Does anyone have questions on that? That is a pretty reliable way to find out if two things are inverse of each other. Take one formula and try and get a letter by itself. Now the problem is sometimes that's not possible, or at least it's not feasible. You know, you've heard the word feasible before? It's like, is it possible for me to walk to Washington, D.C.? Yeah. Is it feasible? Heck no. First of all, I'm not in shape. Second of all, it's like over 1,000 miles, or 900. It's something huge amount of miles that I would collapse gasping probably before I got out of Grand Rapids, but definitely not walking to DC. So it's not feasible. There are some things you can get y by itself, but it would take 45 minutes and a whole bunch of pain, and just say phooey on this. It's not feasible. Example. What is the inverse of y equals x cubed minus x plus 1? This is going to highlight the second thing I want to go over today, which is, you notice sometimes when I get y by its, or when I do the inverse, I then get y by itself. That's what I did over here. We switched the x and y. This is, in a certain sense, done. That is your answer. It's just not simplified because they don't want y by itself. Can somebody give me the inverse of this thing? Blaze, help me out here. What's the inverse? How do you get the inverse of anything?
Switch legs away.
Right, do it.
So,
Wherever there's a y, put an x. Wherever there's an x, put a y.
X. Is it just X?
Yep.
Okay, X equals Y cubed.
Uh-huh.
Minus Y.
Minus y plus 1. Ta-da. And then make it y by itself. Now, the only way to get y by itself, can I use algebra? Can I cube root both sides? Why not? Why not algebra? Katie. There's two species of y. You can't get y by itself using algebra. Can I use the quadratic formula? Josh?
No, because it has to be squared.
It has to be squared. Quadratics are squared. This is cubed. Does it factor? What do you think? If you had to take a bet, what would you say? Well, does that thing factor? You're correct, it does not factor. It's awful. This, you're done. There is no feasible way to get y by itself. So you leave it. In other words, if something doesn't simplify, you're not on to simplify it. Or if it doesn't simplify without donating 5 pints of blood and breaking both arms, you don't have to do it. It's too big a price. Questions, Fargo? Right. Now, quick 90-second digression. You all know the quadratic formula by now? X equals negative b plus minus square root of b squared minus 4ac all over by 2a. Are you aware that there's something called a cubic formula? It does exist. It was invented in the 1600s-ish. Brilliant mathematician. I don't remember who did that. I think his name was, and I don't even remember. I'll have to look it up. The quadratic formula, when first-year algebra students see it for the first time, they're like, oh, what is this? It's a monster. And then I say you can get plus 5 extra credit for memorizing it and reciting it in less than 5 seconds. And they say, oh boy, and then it's their favorite thing in the world. The cubic formula is roughly 2 pages long. A teacher friend of mine and I, at my first job, sat down and we had a 1-hour lunch period, if you can believe it. We used our entire 1-hour lunch period just trying one example of the cubic formula. It was sort of like this. It's like, find y. It literally took us like 53 minutes to get and there are 3 solutions. And it gave us all 3 of them. And we plugged them in and we made sure they worked. And both of us were just enough of the math geek that we figured this was actually pretty fun. We starved that day because we didn't eat lunch, but there you go. Is it possible? Yes. Is it feasible? No. By the way, if anybody would Google it, it's probably on Wikipedia too, the cubic formula. It's wild. There is actually a quartic formula for 4th power as well. It's actually only about 2.5 pages because it's based on the cubic formula. There is no power 5 formula or power 6 formula or power 7 formula. A mathematician by name of Abel, A-B-E-L, proved that there is no formula above power 4, ever. Which was totally fun because you don't have to go looking for them because they'd probably have been 10 pages long anyway. So, thank Professor Abel. Anyways, is this making sense? What you need to do in this assignment is, if I give you a formula, can you get the inverse, if it's feasible? Second, if I give you 2 formulas, can you find out if they're inverses of each other? And there are 4 ways to test for that. If I give you a graph, can you give me the inverse graph? we did that the other day on Friday, where you just trade all the x's and y's, not only in the formula, but in the graph. Like if the original graph has the point 3,8 in it, then the inverse graph is gonna have 8,3 in it. You just switch every single point you find, and then finish it. Does that make sense? Let me grab the worksheet. It just came off the, put it downstairs. For those of you listening at home, this is going to be extremely boring for like 90 seconds, so go put on some chicken soup or something. I'll be right back.
No, my mom won't buy me anymore. You just get like just the old remote ones. They're so good. No, you can get 72 for $10 at Costco, and my mom will not let me go to Costco. No, but that only lasts me like 2 weeks. Like when I add like 8 a day. It's so nice. Did you guys know? Is that the first time you heard that story, or was that just me?
No, that wasn't the first time.
Wait.
I spit out my mint.
That was a dream.
Yeah, no problem. No problem. Oh, and Chandler, I will email you one of these.
There's California.
He like yes.
I'll probably
He's like,
We take a quick look at the sheet. Problems 1 through 4. Find out if they're inverses. That's any of these 4. Again, I did not give you a graph, so unless you just absolutely adore doing graphs, I would choose one of the other methods. You can if you want. Problems 5, 6, 7, 8. Get the formula for the inverse. Now, one detail I'd like you to do, everybody can look up here real fast. Everybody? You notice how I took f, replaced it with y temporarily, and then down at the bottom? Does anybody have a problem? This is y, and this is y, but they're two different formulas. Technically, I should have done this. Because it's not the original y, it's the inverse function. If you want, what's better, and what the worksheet is gonna ask you to do, is this. Replace the y with f inverse of x. Or replace y inverse. Does that kind of make sense? Once you switch it, it's no longer the original function. So I can't really call it y anymore. I have to call it y inverse. Then I just rewrite it as f inverse. That's what I'd like you to do for 5, 6, 7, 8. Number 9, graph the inverse and then graph its function and its inverse. Notice, on number 9, 10, 11, 12, you need 2 graphs. The graph of the original and the graph of the inverse. They shouldn't be terribly hard to do. Just beware. Look at the trick up here. If they give you a formula like this and you say, how on earth am I going to graph this? Dividing the whole thing by 5 is the same thing as dividing each one by 5. So this is not exactly the happiest thing to graph, I understand. But, first of all, yeah, number 10, for example. It's going to be an annoying, number 9 and number 10 are going to be a little annoying to graph. Because they don't have whole numbers for y-intercepts. Label them if they're not whole numbers, round numbers. Label them. Like at number 9, the y-intercept is -5/2. Put a dot there, but label it -5/2 or -2.5 or something like that. Does that make sense? Shouldn't take a horrendous amount of time to do this. It's a relatively short assignment. If you get done with it, you're welcome to work quietly on other work. Call me over if you get stuck. Otherwise, go to it. And Shaylee, Godspeed your health. Talking with you soon. Cheerio.